We're live, and thanks and welcome to tonight's live coverage of the approach of Comet Siding Spring to the planet Mars. This is coming to you live from itelescope.net backup site Epsilon, as I like to call it, which is my office in Ringwood, Wonga Park, Victoria. So thanks for joining us tonight for this momentous event. We've been looking forward to it for months now. We've been following the comet across the night sky, and we're just loving this. And we're going to share with you some of the science that the amateur community has been putting together. We're going to talk tonight to Dr. Padma Yanamandra Fisher, who's part of the PACA COIC Siding Spring Alliance, but right now we're going to go straight to Paul Stewart in New Zealand, who's got a live image of Mars and the Comet Siding Spring. Now, you'll notice here, I'll get Paul to comment in a minute, but it's going to be a very faint green dot about 3/4 of the way to the top of the screen. So Paul, how are you in New Zealand tonight? You're a couple of hours ahead of us, and I think you're getting pretty low to the horizon there, about 25 degrees above the horizon. How are you?
Yeah, I'm well down here.
That's good. Well, thanks for bringing us these live images here. So the advantage of your backyard telescope is you can get really low to the horizon. We're going to be taking some images off the scopes at Siding Spring in about half an hour. So do you want to just highlight where Comet Siding Spring is in that image, Paul? Thanks.
It's right here.
That little tiny green dot up there. Wow. So it's very faint compared to the very bright planet Mars there. Yeah. So what are the conditions like there, Paul?
Well, it's clear at the moment. It's a bit hazy. We're pretty low to the horizon, so we're in the muck at the moment, so it's a bit red and hazy over this way.
So just while we've got you there, I'm going to introduce now Dr. Padma Yanamandra Fisher. So Padma, do you want to introduce yourself and say hello to Paul?
Hi, Paul, Peter. Thank you for having me on the Google Hangout. My name is Padma Yanamandra Fisher, as Peter has already announced. I am a senior science research scientist at Space Science Institute in Boulder, Colorado. I am also a member of the Comet Integration Observations campaigns for Siding Spring, as well as we started this with the ISON last year. And I now have an expanded network of amateur astronomers with wonderful people that we're going to be showing and talking to them later today.
Great. So thanks for joining us. And so what city of the world are you in today?
Well, today I'm at home. It's about 3 in the morning, so.
Oh wow! Well, thanks for getting up and sleep clock.
Well, you know, comets and planets don't wait for anyone.
No, that's true. They don't. So we've been waiting for this one for many moons. So
definitely.
Yeah. So Paul, how much longer do you think you will have your live images there?
Oh, another 20 minutes, half an hour, possibly.
Okay, great. Yeah. So because you're a couple of hours ahead of us, so it's getting very low to the horizon in New Zealand. And we did have Paul Harper before joining us from Perth, but he's having some technology problems as well and was going to log on from his other computer, so he might be back with us in a little while. So thanks, Paul. There's really great images there. Now, do you want to just tell us a little bit about your telescope?
At the moment, we're using a 132mm refractor with just a standard DSLR camera stuck to the back end of it.
Oh, that's great. Awesome. And the advantage of that is we get a very wide field of view here. So I think a little later when we get to image it from T31 at Siding Spring, Mars will be absolutely blown out of all proportion. Of course, we'll have a good shot of the comet, but the Mars will be very, very, very overexposed because we've got a quite a deep sky set up there. So that'll be interesting a little later. So so that's great. Now, Paul, you had a shot you took a little earlier. Do you want to just share that with us quickly, and then we'll get some commentary from Padma about the project and what we've been doing. So yeah, here we go. Now, do you want to talk to us a little bit about this image, Paul?
It was a pretty quick image. It's only 320-second images integrated together, just a couple of dark frames.
It looks pretty damn good to me. So, yeah. And any of our guests who are online and you want to tweet around, you know, or get some extra people to join us, we're going to be online for the next 90 minutes or so, or next 1 hour to hour and a half. So, so thanks for joining us tonight. So Mars there is very overblown, obviously, because it's such a bright object, and the comet's roughly about magnitude 12, about 13, I think, at the moment. So that's why it's very faint compared to Mars. So, yeah.
Oh, excuse. When was this taken, Paul?
About 20 minutes, half an hour ago, wasn't it? I think.
Yeah, you've been getting on to about an hour ago now.
Yeah.
We're fortunate that the comet seems to be in a relatively clear part of the sky.
Yeah. So it's actually travelling through the dark dust lanes around the centre of the Milky Way at the moment. So the last 2 nights, you can actually see that the darker patches in this image are not actually lack of stars. They're actually dust in front of the stars that are behind them, which is quite amazing in itself. So, all right. So I'm just going to, thanks, Paul. I'm just going to briefly share with you a slide here that I've got, which is about the PACA item. Oh, it's not quite the slide I thought I had. Where was it going here? It's not it. I'll share it anyway. This is the. I'm sure you're getting that okay. There we go. This is the. It's not very helpful, is it? I'm going to stop screen sharing. That's not the exact image I was after. So basically, just to tell you a little bit about the PACA Eye Telescope collaboration. Eye Telescope, as many of you may know, is a group of robotically controlled telescopes on the internet that are put together by a group of members and affiliates who use these telescopes and share access to them through subscriptional accounts. And it's one of the world's premier robotically controlled, publicly accessible telescope network. Every member gets access to their own files and can plan their runs and apply their various filters and settings. They have complete control over that, and you'll see that in a little while as we go live on T31 in about 20 minutes from now. And across iTelescope, there are a number of members who are really interested in science, and we've pulled together a team of about 5 or 6 people, a couple of whom couldn't make it tonight at the last minute, so apologies from Sharon and Paul, and Namal had some technology challenges there as well. So we're hopefully going to share some of their images before we're done. So it's been a great little team of people who've been just gently following Comet Siding Spring over the journey for quite some time now. So since it was discovered last year. So iTelescope put aside a grant for some time for this group of researchers or amateur astronomers who are doing this research on the basis that there are a number of things about comets, and Padma will touch on this in a minute, that are quite important. There's a group called COBS that are based in Europe who've done some brilliant work using the focus application to look at the dust discharge rates and the apparent visual magnitude. Padma has asked our team to concentrate on the R and V channels so that we can get FITS files and high quality images of Comet Siding Spring in those two filter channels. So that's what we've been doing, and we've got a light curve that I'm going to pull up in a minute. I might just share that with you now. And this light curve has really been the product of some amazing... my light curve gone. Lost it. I might hand over to Padma while I find it. So Padma, I'll hand over to you for a bit, and you can just share with us the some of the work and the collaboration between not only iTelescope but all the amateurs around Australia and around the world, which you've been coordinating.
Okay. Well, thank you very much, Peter. I'm just trying to get some of my slides up. Given so many talks that I want to make sure that I acknowledge everybody properly. Let's see. I basically was part of a neat little team called CIOC in 2013, which stood for Comet ISON Observing Campaign. At that time, Comet ISON was a dynamically new Oort cloud comet that was coming in and was going to fly by the inner planets. But as we all know, it disintegrated on its perihelion day. And so we were repurposed, and now we are the Comet Integrated Observations Campaign. Siding Spring is our new target. And out of that, apart from the science, what evolved was an interaction and synergy between professionals and amateur astronomers around the world. Also leveraging several social media so that we could, in effect, actually have a worldwide observing team, and that helps in a lot of ways. Primarily to get a long timeline of data that we normally would not have been able to get using only professional telescopes, since we have to compete for our time there. And so this long timeline of data from the amateurs certainly helps in creating a background against which you can compare our professional data. But also, because of the weather and different geometries and different locations, we actually get a good legacy data set that we can then compare for other comets. And with new techniques and equipment that the amateurs have, that line, the gap between the professional and the amateurs is getting closer and closer, it's blurring, so that we are actually able to do a lot of science. And so we are now trying to integrate the amateurs as partners, and the synergy between the different missions and the different spacecraft, professional telescopes and amateur telescopes, we're starting to see interesting results. We're seeing the evolution of the comet as it travels through on its path. And Comet Siding Spring is really very interesting, and I think having this Google Hangout in Australia signifies a special place it holds there, because it was discovered by Rob McNaught at Siding Spring, the Uppsala Observatory, and part of Siding Spring Observatory.
Yeah.
And so I think it's very dear to a lot of the Australians in our network. But it's also very interesting because it's also a dynamically new Oort cloud coming into the solar system. But it's interesting even more so because it's going to go by Mars, as we all know, and that's what we are waiting to see what's going to happen today. Now I'm going to try to see if I can find a couple of graphics where I actually have...
Got that light curve now, so
okay.
do you want... So here's the light curve that the iTelescope PACA team has put together. And we haven't got a curve to join all the dots yet, but you can see how it was brightening, and then it went through a little bump as it brightened quite steeply as it moved towards Earth, and then as it moved away from Earth again, sort of leveled off. And just in recent days, in the last couple of weeks, it's faded quite sharply. So this is our little light curve here that we've been working on as part of our team. part of what we're doing is making sure we've got all the FITS files that we can share with the professional astronomers should they want access to them. I mean, a lot of professional astronomers are doing their own images, but it's good to have a baseline set of amateur images as well to compare them and do, good science with against as well. But Padma, back to you.
Okay. Well, I'm just trying to share. I don't know if do you see my
Yeah, we've got
screen?
that. Yeah.
Okay. That basically is a map, an atlas of where we have our amateur astronomers, and you can see that. Well, it's an increasing map. So this is from about a week to 10 days ago. We haven't added a lot of other astronomers, but what you can see is that we have quite a few red dots around Australia and Europe, and so we have a good concentration of northern and southern hemispheric observers. And on the right side, what you're noticing, what you would see is Bob McNaught in front of the Uppsala telescope where he discovered this comet, and the lower picture shows really the telescope itself. So this is really a quick glimpse or glance at the network we're building. And what the advantage here for Siding Spring is that it's a southern hemispheric objects, all of the interactions taking place in the southern skies. And so we have a nice network of amateurs in South America, South Africa, as well as Australia. And so this has provided a new dimension where we can coordinate amateurs in a certain part of the world. Many of the northern latitude observers can't see the sun except through the robotic networks like eye telescope. So we are taking advantage of the new way of doing amateur astronomy, and that I think is an important aspect. A lot of the professional telescopes are looking at it today, are looking at this event today, as well as a lot of spacecraft around Mars. But from January, the ground-based observations have really been the amateurs, and that's been kind of a timeline against which we kind of are trying to coordinate what kind of observations should be done from where they should be done. And so I am very grateful and happy to have this amateur astronomer network, and I want to thank everybody that has been participating for the last 9 months, I think since January, so about 9-10 months. Especially Peter, because when I met Peter in April on my tour of Australia trying to recruit amateur astronomers, Peter was very gracious to be my host and drive me from Melbourne to Siding Spring to look at eye telescope and all the other scopes out there. And we did this entire fantastic trip in 3 days, and I don't think I ever want to repeat that, Peter, but it was just a wonderful, wonderful initiation to the different telescopes that are there, and actually seeing eye telescope in operation. Very impressive. And the fact that it has global reach made it even better, because then you could it attracts a lot of the amateur astronomers, experienced as well as novice, and the goal being just getting this legacy data set. And Peter has been the driving force in helping identify the windows that we can observe, also the team members, and the regular observations that he just showed the light curve. It requires a certain amount of dedication to taking the data and actually processing it, and it's another way that the amateurs help is by grouping themselves or forming little groups that can actually do focused science. So the light curve that Peter showed shows that the magnitude, the brightness has decreased, and it's very much in line with what one of our team members on the CIOC science team has done, Matthew Knight. And if you go to the website for our team, Matthew has basically put up the light curve, and also has written a blog about what he thinks could be the reasons why there's a change in brightness. So this it basically shows that the results from the amateurs,
isn't it? Because it hasn't actually reached perihelion yet, because perihelion is actually next week. But it's
right.
not like a sun-grazing comet like ISON was, or like Comet Lovejoy 2011 was. It's not getting anywhere near as close to the sun, so the sun's not acting on the comet in the same way as the sun-grazing comet would act. I'm just going to go back to Paul, because I can see he's starting to fade out a little bit. Paul, Paul, do you just want to give us a last? I notice it's getting a bit hazy there where you are. Last call out from you. You can stay on and provide commentary and share some photos, but I just noticed your image was fading out there a bit.
Yep, we're right down in the soup of the atmosphere now.
Yeah. So if we can just see that little green dot up there, it's so has it visibly gotten much closer? Because I think it's travelling at about 1.5 arc seconds per minute, isn't it? At the moment.
Just got an image coming through now showing how much it's moved.
Yeah. Okay, that's great. Sorry to cut you off there, Padma. We're about to lose the live shots from New Zealand here, so I just thought we'd zone in on this. And Pal's got a nice image for us. He had up there as well. Pal, this one's from a couple of nights ago, I think. Lost that one as well now. Okay, oh, that shows how far Mars has moved in the time. That's amazing to think that Mars is actually moving against the background stars by that much as well. And so what Paul's doing here is just taking the two images and overlaying them on top of each other to show how far Mars and how far, because not just the comet coming towards Mars, Mars is actually moving almost about the same speed across the background stars. So, Paul, do you just want to highlight that with your cursor again for us?
Well, the two little dots with my cursor is now is the comet. Yeah. How much it's moved over an hour.
Yeah, wow, that's amazing. We've also, sorry, that's not what I'm sharing because it's over the top of the window. Oh yeah, so the two little green dots there. So you just want to go to the left-hand one and then to the right-hand one just to highlight it, there to there. So that's how far the comet has moved. So this is two images, what, an hour apart, is that correct?
Yes.
And so you've double imaged them over the top of each other. So we've got two comets and two Marses in this image, if that makes sense. And you can actually see how far. So do you want to move your cursor to where the crossover point's going to be? So up in the top hand. So sort of, you can probably work it out from there. They're going to cross over in about 8 hours, or about 7 hours probably from now, which will be over the horizon limits in Australia, so we won't actually see that ourselves. But I think our South African friends will pick that up tomorrow, and they'll be in the box seat for that tomorrow morning. So Padma, back to you. Thanks, Paul. That is absolutely brilliant. I'm very impressed with that, and thanks for putting that together on the fly. Feel free to stay on, and we'll come back to you maybe for some commentary shortly.
Thank you, Paul. That was wonderful. I'm trying to share a graphic, Peter. I'm not sure it shows up.
Yeah, it's not at the moment. Just hit your share button again and just unshare it. There might be a banner across the top of your screen that's got share or share with everyone or unshare.
Okay, do you see that?
Now, I've just got...
okay, I found it. Okay, the graphic that I want to share, this is very similar to what Paul was just showing us at the two images. This, basically what this is a composite of images taken by Rob Kaufman, who is in Bright, Victoria, Australia. And Rob was one of the first ones who actually took a nice wide field image several months ago to kind of show where the comet and Mars were in the field of view and their paths and the where they would encounter on October 19th, today. And so what this is you can see the red arrow is the direction of the motion of Mars, and the blue arrow corresponds to the motion of the comet. And as of yesterday, you can see the latest position is this little crosshairs. There's the comet here, and there's the planet Mars. And so over a matter of 3 days, this is from October 15th, 17th, and 18th, 3 days, you can see how the two objects have been moving. And so, although Australia won't be able to see the actual time of event, we are sort of on this path. And so, what Paul showed us in real time is really something around here. And so, this is what is interesting: is not only do they cross each other, but it's also in a very busy field. So, with all the stars and Mars is so bright compared to the comet, it does wash out the comet. But this is what we are aiming to look at. And from South Africa, this event is able to be viewed, and so we're hoping to be able to have amateur astronomers and professionals there actually taking data from South Africa in a few hours. So this, I thank Rob Kaufman for this. This is a beautiful composite, and with Paul's data, we're starting to get closer and closer. And so this is one of the graphics I did want to show, is simply because this is a real-time evolution over the past few days. And then there's another one that I would love to show is we all talk about, where's the share, unshare button? I'm sorry. Peter, where did you say the share button was?
Just on the left hand, the green box.
Okay.
Stop sharing.
Okay, I just have so many that, okay. Oh, what's that?
That's me. That's right. I'll put you back on the big screen.
All right. Here we've been talking about the comet, but interestingly, even Mars is interesting in the sense that from the time that we started the observations in January till now, Mars has undergone different seasons. And so right now it is the northern fall, which is equivalent to the dust storm season. And so one of the amateur astronomers from South Africa, actually Clyde Foster, recently took some pictures of Mars, which actually show dust storms that are breaking out on the planet itself. So the planet too is also changing. So sometimes having more dust in the atmosphere can change the opacity through which one looks at the comet. And so I'm very, very impressed that with Mars is about 6 arc seconds right now, and yet one can resolve dust storms. And I'm trying to find the graphic to share with you. We just got this last night, I believe, from Clyde, and it's as recent as you can get. So let me
hit that share button again.
Okay.
That'd be great. Thanks.
Go back to my
just while you're doing that, on my screen I've got the all-sky camera here. It's quite clear in Siding Spring. You can see down the bottom here the 3.9 meter AET in the all-sky camera there, and this is the Milky Way. And with the dark dust lanes is where the comet's going through here at the moment. So we'll come back to that shortly. We're going to, as soon as the run starts, in about 5 minutes, I'll show you the live images that's going to come off T31, which is a deep sky. We'll get a lot tighter to the comet, and hopefully Mars won't be too close, but it probably might be in shot. We don't know. Anyway, Padma, talk us through these dust storms. These are brilliant images.
Yes, here I'm showing the image of the image of Mars and different wavelengths. This is given to us, shared with us with Clyde Foster. As you can see, there's a lot of activity and bright features, and so these are supposed to be dust storm cells that have started, and they're showing activity. And this is they're going to be watching this for the next few days, but it's very interesting that this is happening around encounter time, but this is a dust storm season on Mars. So Mars itself is a very dynamic object, and looking forward to what wonderful high-resolution images come down from the Mars spacecraft, or the NASA's fleet of Mars spacecraft, as well as ESA Express. ESA has Mars Express and Indian mission MOM. And so it would be very interesting to see any of these influence of these dust storms on the images of the comet itself. But this is the kind
Yeah.
of this is the level of interaction with the amateurs that we are trying to develop science from looking at these kind of data sets.
Yeah,
So
so
it's
when
fantastic.
we're looking at an image like that of Mars, there's not only the collection of the raw RGB images, there's about an hour of, or at least probably multiple hours of image processing time that's gone into that. And of course, professional astronomers, don't necessarily have the time or the bandwidth to do that night after night after night. And that's where the amateurs really add some value to the collaboration between professionals. So, of course, we know Anthony Wesley here in Australia, who's a absolutely master craftsman of imaging of planets and the like. And there are a number of others, he's just one that comes to mind, but who've done this. And I'm just waiting for the shot with a whole year's worth of Mars sort of, rotational high resolution graphics, and then the comet sliding past it that they're going to collect over the next couple of nights. It'll be absolutely brilliant. So,
Well, and also comets. Um, this is not the first time, right, that a comet has gone by a planet in addition to Earth. But in 1994, comet Shoemaker-Levy 9, or dead comet SL9, went swung by Jupiter, and as it's from its previous apparition, it had split into fragments, and they all impacted Jupiter. So that was the first concern when one heard that a comet is going to go by Mars, whether one, it would impact Mars, and two, since there's so many spacecraft around the planet, what kind of damage or risk would be sustained. And so that was the first priority, was to identify the path and to determine what type of dust material was heading towards Mars and what kind of mitigation procedures should be implemented. And so that was what the science team CIOC did, was they had the studies to basically see what the impact would be, and found out it would be not very much, but still there's a little bit of a risk. So the spacecraft have been kind of maneuvered into a safe position after
So just talk us through that. How many spacecraft are in orbit? I believe about 5 or 6, is it?
Yes, there are 5 orbiters around Mars. 3 of them are U.S. NASA orbiters. MRO and Maven is a new spacecraft that just arrived in September. And then, the third one is slipping my mind. And then ESA, European Space Agency, they have a spacecraft, Mars Express, MEX, which is also in orbit. And then Indian mission, MOM, Mars Orbit Mission by ISRO, was also arrived 3 days after Maven. So all in all, there are 5 orbiters, and then there are 2 rovers, Opportunity and Curiosity, on the surface. And so between all the instrumentation and the different geometries over the next few days, the aim and the goal is to study not only the comet, but also try to see if they can resolve the nucleus of the comet, and then to see if there are any of the cometary dust, if it falls into Martian atmosphere, if there are any meteors in the atmosphere. So the rovers on the ground, on the surface of Mars, will be trying to identify that. So there's a huge amount of science built into the various observations. There's a graphic on the NASA website about not only the timeline, but all the different instruments and what science goal they have. And it's a huge, it's a very elaborate program. And in the next few days, we should be starting to see some data. Of course, the data has to come down. It has to be processed. So there is a little bit of time built into that. So it may take a little longer than instantaneous results. But I think we can expect to see some beautiful data sets.
Well, something that you won't see, or that the professionals won't see, I'm not being cheeky here, but they won't see telescope being driven by an iPhone, which is really quite special. So I just thought we'd share that with you. The run, we've just started our run on from T31. I'm not sure we're going to get 18 images out of it, but here we've got the script running. and we're currently taking a 120-second image of from in the R filter. Now, you've been talking to us about getting good data in the R filter. Do you just want to explain the difference between the R and V for us, and why that's important to have that data?
Right. Well, comets are is a mix of lots of different types of material, ranging from ice to dust and other hydrocarbons and volatiles. And so, as we observe from Earth, as from the ground-based observers, we see a lot of as the activity increases is when we start being able to actually see the comet, because it's light being reflected off the gas or dust particles in the comet's coma. And so the reason that we select R and B as the diagnostic filters is that R is very sensitive in the red to the dust material, and V or B is very sensitive to any gas. And so by being able to monitor the comet in those two wavelengths at a minimum, gives us an idea of how the gas and dust structures are changing in the comet. And so as dust activity increases, sometimes you'll see some burst happening in the nucleus that we may not be aware of, but it might enhance the brightness of the comet. And so the variation of the dust through a calculation of parameter called AFRO, which was introduced by Michael Hearn many years ago, is a way of comparing images and data from different telescopes and different apertures, but also to as a proxy of activity of the dust. And so that's why R is extremely important. And as the dust activity increases or decreases, you can kind of monitor that through this. And there are other campaigns also that do take amateur data and look at dust morphology in the coma. So that's very important because we can't see, we can't measure all of these parameters all the time. So trying to identify diagnostics and measurements like this as a proxy of that that kind of science is very, very important. And then whenever the pros take data that give us a high resolution and more refined data, we can then cross-correlate between the observations that we have in R and B. And B definitely is, like we saw in ISON especially, towards the end, the dust activity stopped, but then the gas, the production rates of some of the species increased, and so the brightness in V was much higher, and so V is very important to see how the gas changes in the coma. And so one of the common filters that most amateur astronomers have is the R filter, so that's why we wanted to have a consistent data set. So we asked almost all the amateurs to at least record in R so that we can have this long timeline of dust activity.
Yeah, so here's the latest image off the telescopes. This is the first one from T31 at Siding Spring. You can just see the comet up here. In the very center of the image, little fuzzy dot there, and again you can see how overexposed Mars is in a 120-second image. So that is great. That's a good shot. So that's the first one off the current run that we've got, and amazing image. So we'll add that to the photo stream as we go through tonight. I'll just see if I can do that shortly. So yeah, this is live, literally straight off the telescope 120 seconds ago. So I'll come back to you now, Padma. Can you see the comet there?
Yes.
Yeah, just a very faint dot right in the dead center of the screen.
Yes, it's very interesting that its brightness has been changing, and so we don't know exactly what's going on. So this is one of the most interesting questions that we're all waiting to find out. Is this an intrinsic change in brightness? Is it? It can be just the geometry. It could be the busy star field that the comet is going through. But all of these can be only factors, and we still don't know why. And so that's a very important question to understand what's going on with the comet right now. Also, but also since it's getting close to perihelion, sometimes you see features in the comet from ground, but it would be interesting to see how the comet, as it swings by and approaches its perihelion, what the dust structures really look like.
Yeah.
And this is something that hasn't been done before, so it'll be very interesting to see what unique observations we get.
Yes, that's right. So that's quite exciting, isn't it?
Mm-hmm.
Yeah, so Paul, your thoughts, how are things going there in New Zealand?
I think it's time to pull the plug here in New Zealand.
Time to pull the plug, yeah. I don't know if we've got one last shot of you there. It's sort of, the images you've been bringing us tonight are absolutely terrific, so I want to just thank you and commend you for, how cold is it there? It's not too chilly for you?
Yeah, it's fairly warm tonight.
Yeah, it's fairly warm. Good, good. All right, so Paul Stewart from New Zealand. You got a Twitter handle or something, or a blog you want to just mention there?
You can find me at Astro Stew on Twitter.
Astro Stew. There we go. So anyone who'd like to follow Paul, Paul's a very keen contributor. Wonderful amateur astronomer. We regularly see him online and in the Hangouts, so it's great to have you on board. So thanks, Paul, for joining us. Feel free to stay on if you'd like to. I just want to share, Padma, with you a couple of things. Just while we're waiting for the next image to come down. One of the advantages of having amateur astronomers doing this work is that you come across things that you might not have otherwise seen, right? Because who's going to be watching for, as good as the planning might be for a run, you quite often come across unexpected things in an imaging session. So I'll just click on that. So, what we've got here, and I'm hoping you can all see it on your screen. It's kind of a bit high up on the screen here, but this is a series of 4 images. Can you see that, Padma? Okay.
No, my screen. Oh, okay, I see it now, but my screen only shows me, so
Yeah,
I don't know if I messed up.
So yeah, it's up on the screen there.
Yes, I can see that.
So what we've got here is a grazing occultation of a background star, and you can see as the comet moved across in front of the background star, its magnitude was 13.8 in the V, and then as it went across in front of the star, it popped up to 12.2 and then to 11.5 just in a matter of minutes, right? Because here you've got a background star and a comet right over the top of each other, so all of a sudden they're a bit bright. And if you see up in the top image here, in the top right-hand corner, image pane number 2, you can see just as you've got the background star just encroaching, see there's a very nice smooth little U-shaped dip there, which shows that it's quite clean. So we've got 2 nucleuses coming together, and we know that there's not any other bits of comet that might be just out there floating around because we've got a quite clean line. And quite often what happens with grazing occultations or repulses of asteroids and things is that often there can be a double bounce in the light if there's a second little nuclei or a bit or something that's broken off. So I thought this was actually quite interesting to share with people because it was one of those kind of things that you didn't plan for as carefully as we do plan for images of where the comet is. It was just a case of, in this particular series, the comet actually went across in front of a very bright background star, and just showing how that changed the light curve. It was quite a fascinating thing. And quite often amateurs will pick up interesting things like this that that you don't necessarily plan for, or are a little unexpected at times.
Well, I think the follow-up on that point is the response time from amateurs is faster only because of the immediate access to equipment. With professional telescopes, we do have access to, we do apply and do get time for what we predict. And also there are times when something happens and we immediately get time from the big telescopes also. But we're also at the mercy of weather and loss of observations. Case in point, I was in Hawaii just a few days back to look at Comet Siding Spring in mid-infrared, which is hard to do. There aren't all that many facilities in the world. So I was at an 8-meter telescope, the Japanese Subaru telescope, with a mid-infrared imager spectrometer to get an idea of the brightness temperature, like a thermometer, it's like a thermometer in those wavelengths, so you know how much how bright the comet is. Unfortunately, we had technical issues, and out of a 12-hour night, we lost 6 hours, in which included the window to look at Mars in Comet Sighting Spring. And that was it. We had the one night, and so we lost the night. And there's nobody else that I know that is doing that from ground. We may get some information from some other spacecraft, Mars spacecraft, as well as other orbiting telescopes. But the opportunity is lost. And so, of course, amateurs can't do mid-infrared astronomy from ground. But the point being, if it were another wavelength, you'd have amateurs can at least go back night after night at different times, or if something's happening by through Facebook and other social media, they can basically connect with each other and say, this is what's happening, and hand on the baton, so to speak, so another amateur astronomer can pick it up. So there are advantages and disadvantages of both communities, and this is where the synergy between the two becomes important by being able to address some of these. And like Peter said, unusual events or events like this occultation, or even any other features that you would see, geometric features on the dust, they were transient features, and so again the immediate response would be from the amateurs, because they can spot these and let the professionals know. And so that's a really wonderful partnership.
Yeah. So just coming back to our light curve, here are a couple of the images, one from back in August. Now, what we did in our group, and this is a little bit different to some of the other groups, as I said before, what some of the guys in Europe were doing, using the RMV filters. Comets are notoriously difficult to actually get accurate photometry on, because it depends on what the surface brightness of the comet is, how many background stars, or how busy the field is. And as you can see, the later images in the last month or so, it's been in a very busy field. This is one from back in August, and you can see this is using a program called Astrometrica. And normally, if this is an astrometry program, which is more used to tracking asteroids and comparing, and yes, sampling some of the photometry as well. But as you can see here, the point spread function of a comet is very different to the kind of normal point spread function of a very bright, tight star. So the challenge is how to set your aperture to a point where you actually get the most appropriate aperture setting, depending on how bright the comet is. Again, the focus technique that some of the European guys who are working in the COBS group is a little bit different. They use some advanced software to back out the background and come up with some very high precision results there. What we've been mainly focusing on is just using Astrometrica as it's normally used, but using the best catalog, which is UCAC4, for in terms of the photometric catalog. But then we've been going back to another method, and for those who aren't familiar, what you do is you put an annulus over the comet, and it's just like an Excel spreadsheet. So every pixel counts the number of photons of light that hits each pixel of the camera, and then it develops this thing called the flux, which here you can see is about 85,000, if my 54-year-old eyes can read that correctly. And so, but it can become quite problematic, because if the comet gets very dense and the comet gets very bright, well, how do you then compare accurately the brightness? And this point spread function starts to flatten out, and it's not really a good indication of the real brightness of the comet. So what we did in our group, and I'm going to write this up because, the best practices in this area, there are a number of different approaches to it. And what we did, just to compare a sample, is we went back to the to the APAS catalog, which is a catalog from the American Association of Variable Star Observers, and that catalog has got a whole heap of standard stars that they've done a color survey on. So, for example, here we were able to identify reference stars in the field that had a B minus V, and sorry for the technical terms here, but the blue channel minus the V channel of greater than 0.5 and less than 1.1. I'll simplify that for you. The red ones here are ones that are greater than 1.1, and what you're doing is taking a color measurement in two different filters with a monochrome camera of a star and comparing them in the two different filters to find out what color the star actually is. And as many of you would be aware, red stars are particularly known to be variable, so they're not really good reference stars. So what we did is we went into the APAS catalog, developed a star chart in the V channel for us, and then we came back and did a high precision photometric analysis using VFOT, which I'll just share with you. And that's an American Association of Variable Star tool, Variable Star Observers, and this is this star field where we've chosen these particular reference stars off that V channel, and then we've used those as known reasonably good quality reference stars to then put the annulus over the comet and do a comparison. And then when we've gone back to Astrometrica, we've selected an aperture that's consistent with what we're seeing here, so that it's kind of like a benchmarking of our aperture size. And you know, we haven't used the Focus software tool. We've just been concentrating on the individual color channels, and we've been periodically using this to set up baseline for our setting of our aperture. So it's probably not a perfect method, and I'm perfectly happy to accept that there'll be opinions out there about whether the value of this. But we've got all the original FITS files, and we're happy to share those with the professional astronomers through PADMA's collaboration, and all our background star charts that we're making for each one of these frames. So, PADMA, what are your thoughts on that as an approach?
You know, I was curious about that. It does make sense to try to take an aperture close to the size of the nucleus. So, and I guess I've been looking at some of your data, and I think you were wearing the aperture with function of time depending on what the comet looked like. Is that right?
Yeah, so when it was very faint and there were lots of background stars around it, we've used a smaller aperture. The problem is if you get the aperture, you can actually change the magnitude of your measurement by 1 or 2 magnitude depending on what size aperture you pick. So it's actually quite problematic, and that's where the the COBS team have got a very refined technique that they use, and their magnitude is a little bit higher. But I think in the math behind that, they actually partially factor in the Earth to comet distance into that to give that apparent visual magnitude. So anyway, we're having a lot of fun. We're not professional astronomers, and we are doing photometric measurements that are populating our light curve, and the raw FITS data that we have in each color channel, we're making available to the scientists through PADMA's collaboration, so they can go and do with that what they want. So, and if any scientists watching tonight who want access to those images, through this collaboration we have with PADMA, we're happy to share what we've got there. Just while we're on a break here, I'm just going to go to Pal. Pal Brillas is having a few technology challenges tonight. He's got a slightly wider field of view here that he's just pulled off T32. So again, we've got Mars very bright. Now, this might look further away than in the previous shot, but the field of view is not the same in every one of these images that we're sharing here. So actually up the top corner here, I think you can see the comet up there, and Mars down the bottom right hand side. So thanks, Pal. Pal's been a great part of our team on the iTelescope PACA collaboration, and it's good to have him. He's been on T32. I think I'm having a few challenges with T31. It's not tracking properly at the moment, but we did get some nice images there for you. Coming live to you tonight from Siding Spring in just west of Kinnabarabran in New South Wales.
Peter, can you basically introduce the team or where the viewers are, just to show the power of robotic networks? You can be next door to iTelescope in Siding Spring, you can be in Italy, you can be in North America, and yet you can have a team together to work on this.
Yeah, that's right. So we've had Nimal Paul, Pal Brillas, we've got Sharon Ahmed, who's got the flu tonight and couldn't join us. So big shout out to Sharon if you're watching this, and it was great to catch up with you a couple of weeks ago in Siding Spring. We've got Chris Watt has been doing an absolutely brilliant job as a visual observer. And he's been out there almost every other night with his telescope doing visual observations and sketches with his images, and he's created a form for visual observers right across the whole community where they can actually submit their own visual observations and follow his easy to follow form and checklist there. And so Chris, thanks for doing a great job with that. Also, we've got, I'm probably going to forget someone now, aren't I? we've got now there's a number of people that you've been working with, Padma, who I haven't had so much to do with. So do you want to do a couple of shout outs to your team and the rest of the extended team? I think Paul Harper in Perth was one.
There are several observers in Australia that I'd like to say hi to and acknowledge their contributions. There's Roger Groom out of Perth, and Rob Kaufman out of Victoria, Chris Wyatt from Welcome, Australia. The names are new to me, so I'm trying to remember them correctly. We have Terry Lovejoy, Ron Knight, who also is another visual observer and has been prolific in his observations of various comets and submitting them to our groups. Susie Webb, there's Terry Lovejoy, and if I left out anybody else, I apologize, but I probably should have had a member list here. But we also have observers out in South Africa, Kos and Alan Versvold. In South America, we have Andres Chapman. Actually, Andres was one of the first ones who used a remote login whereby we could actually participate in observing runs while he was taking data. So, and then we have Raul Malia, Carlos Colazo. So there are a lot of interesting places that we have amateurs that are being partners with us by submitting the data, and we're also, and I have to admit, being an amateur astronomer is very difficult. I have been learning a lot myself, and this has been a great learning experience. Plus, also it has opened up new vistas for us because, in addition to Siding Spring and ISON last year, we do have groups that are observing other comets that are of interest, that are bright in the sky right now. If I can, I'm going to try to show one graphic that shows a little sample of the type of data we've been getting from Australia, South Africa, and South America. And it basically, it tells me that not only is this of an interest, but that the amateur community itself is advancing in terms of data reduction as well as data archive, as new techniques, like Peter was talking about determining the light curve. And so these are very, very interesting ways of looking at the data that I want to encourage and also promote more collaborations between the professionals. I think my screen share arrow is okay. It keeps disappearing. I'm sorry.
It pops up on the left.
And it pops up on the left in the slides somewhere. Okay. If for the little bit of gap here, but trying to share the sample of data. And thanks to Peter for hosting the Google Web Hangout, because it's a pretty complicated piece of technology as far as I'm concerned, but it's impressive. It is
a lot
truly
of fun.
impressive. It is, as long as you know what you're doing, I think. And I've, you know what? For some reason I'm scared seeing my screen, but I do not see my graphic. But anyway, I'll try to pull it up as I can. But the point being that you know, this is not the first time that amateurs have actually been part of a campaign. Started out, the first one that I know really is the International Halley Watch, which was one of the first ones where the professionals actually called out a campaign and asked amateurs to join. And it was one of the first ones that was done like this. And consider the time of Halley Watch, there weren't iPhones and Skype, and so everything had to be written out by hand, sent it in, and it took a lot of dedication to a campaign. And so that was the first one. And then we had other campaigns with Hartley, and so amateurs are vital to all these campaigns. And so it's not, even though you may be only observing in R, there's a lot of science that comes out. And one of the areas now that we're starting to get synergy also is in the data format. Like Peter was talking about this data format called FITS, F-I-T-S, and it's a standard that we use for a lot of professional data. And so now the amateurs are starting to provide data in the same format, so it makes it easier to compare, to analyze, to integrate their data as part of the professional data sets. And so these are various dimensions along which the amateurs have been really contributing a lot, and I'm very grateful that they are fascinated enough with comets like we are, so that the common science brings us together. But I'm still having difficulty with my graphic.
The FITS format's the scientific information extension to an image file, and it basically, programs like MaximDL or the Maxim app you can get for a Canon, I think, as an extension, allow you to encode, so much like your smartphone today would encode the GPS location of where you took the photo. The FITS format basically encodes the latitude, longitude, altitude of the telescope where it was taken, the field of view, the focal length, the plate scale, and the start of image time to high precision, you know, so they can actually do calculations on the position of moving objects within your images. So the FITS format is absolutely vital for if you're doing any sort of imaging of, you know, asteroids, comets, all that kind of thing. Contains a lot of valuable information, and the coordinates from the star catalogues and things get saved in there once you plate solve the image, which basically compares a star catalogue with the stars that are actually in your photo, and then updates the FITS file with all the coordinates so that you can then do useful science from that photo. So for those of you who are unfamiliar with the terminology there, that's what it means. So back to you, Padma. You there? You're not on mute. So we seem to have lost Padma just for a moment. Now, Pal can hear me now. So, Pal, can you just put up that last image you took tonight of the comet? Thanks, and just reshare that with us again. That'd be great. And in the meantime, I'll see if I can get my image up again. Let me just, sorry, it's just... You there, Padma? No, she's not there. Okay, look, we might have lost her. I'm just going to reshare this image with you. This is off T31 at iTelescope. We might go out with this in a moment. Just presenting this now. This is off the screen of the iPhone here. So, where are we? There we go. just to prove that it's quite cool driving telescopes with the iPhone. You can see here the image of the comet just there as it's now approaching Mars, which obviously is very overexposed. We can tell we're using a refractor telescope here because we've got a large diffraction spike from the very bright image. And there's Comet Siding Spring up just at a 45, 50 degree angle up from there. You see the little fuzzy dot there. Have we got your back, Padma? No, Padma's dropped out. So I'm left here just talking to you by myself. So we're probably going to wrap this up now. It's been really tremendous having all of you join us tonight here live from the itelescope.net observatory and Siding Spring, driving the telescopes remotely. We've had Paul Brillas from the itelescope.net PACA team, and myself driving one from the iPhone. You just see, that's all right. So Padma's just saying she's crashed out. That's okay. We'll let her go. I think she's been brilliant tonight. So make sure you. Padma has a Facebook group and a Flickr group for amateurs sharing images. So you're more than welcome if you're an amateur astronomer to join those groups. She's back in. Hi, Padma. Sorry, we lost you there for a bit.
Yeah, sorry about that.
Yeah, no, that's all right. We're just getting ready to wrap up now anyway. So there's the final image from me tonight. You can see the comet there, and then we've got Mars down in the corner here. Again, very brightly overexposed with the diffraction spike showing where the difference between a reflecting telescope and a refractor that we had from Paul Stewart before. There's no diffraction spike there because it's a refractor and straight through the lenses. So thank you so much, Padma. I know it's 3 o'clock in the morning there. We're going to let you get back to bed so that you can get up in another couple of hours and talk to our South African friends. And all the best to our South Africans as they follow the approach of this wonderful comet. Comet Siding Spring, discovered in January 2013 by Rob McNaught, and it's going to pass in about 6 hours from now, 6 or 7 hours from now, within 135,000 kilometres of Mars. So for a whole month there, we couldn't say until about March 2013 that it wasn't going to hit. So there was a lot of energetic activity going on, refining the orbit, and it did get refined. We found that it was going to miss, and we'll see tonight. I think the interesting thing, Padma, will be if any of the dynamics of the comet change after it goes past Mars. And I know the professional astronomers are going to be looking very closely to see if any of the dust shows up in the atmosphere, and if there are any after effects or the comet behaviour changes after it passes so close to Mars. So I'll let you sign off now, Padma.
Well, I think this is a great opportunity for this wonderful program between the amateurs and professionals. And I really want to thank Peter, because it is through his leadership and his generosity of time with the iTelescope and pulling together a great team that we have been able to do this project. And so thank you, Peter. Thank you, iTelescope. And I have to say thank you to all the members of the amateur community, not just the ones in my group, but others also, because the networks are extended. And so we have been able to not only learn a lot, but we are getting wonderful data sets. And I want to see this comet again tomorrow, so please continue taking images.
We're zooming in for a nice close look.
That's a great image, and hopefully we'll see it on the other side of the encounter. And then, of course, perihelion is October 25th. And so for the amateurs, I do know that if this comet persists being bright enough for them to follow, they will follow for the next few weeks. So it would be very interesting to see how it plays out as it goes back to the outer solar system and far beyond. Thank you very much. Thank you, Paul.
Past Biden again. Yeah. So thanks, Pal, for joining us. Thanks, Paul Stewart, who's left us a little while ago, who had the early coverage from New Zealand. And thanks, everyone, for joining us. I'm Astro Swanee from telescope.net. You can follow me on Twitter at AstroSwanee, and my blog, theartscope.blogspot.com. That's Artscope with 2 A's. And we're going to sign off now and bid you farewell. And thanks, clear skies, everyone. Thank you and good night.
Clear skies. Bye.